Okay. So we now want to determine the centroid of a shape like this one. So this one is going to be a little bit tricky since it has some sections which are to be ignored or which have been cut out. So how do we do that? The approach is similar to what we did in the previous example. So since we have different shapes, we're going to create a table and we're going to separate or differentiate our structure into segments. So for each segment, we get the area. Since the lengths are in millimeters, we expect this to be millimeter squared. Next, we'll get the extruder. So extruder here will also be in millimeters. Then next, we'll go for white-tube. White-tube as well will be in millimeters. Then lastly, we'll get the product. So we get the product of extruder and the area, then get white-tube and the area there. But what sections are we going to use? Here it is completely up to you. But the current shape that we have here, it is not a perfect shape which we can analyze using a formula. However, if we looked at it first as a complete structure like this, to say that cut out part is present, it's not yet cut out. Notice that we start getting shapes which are regular shapes, which you can easily analyze. So you can look at it as a shape like this, and then break it to say that you have a rectangle at the bottom like this. And then a rectangle, you also have a triangle at the top. This is one way you can approach it. But even better, you can also look at it as if it doesn't just end there. Instead, we can look at it as if we have a full rectangle. We have this going all the way up to that, and then like this. So you can look at it as if you have a full rectangle like that. This way, now we can say it's like this is complete, going up to there. This is complete. So we are assuming it's a perfect rectangle with no cutout parts. So we're getting the centroid of the core structure first. And then we'll see how to account for the pieces being cut out later. So this is the shape whose centroid we're going to find first. This being a rectangle, we know that the centroid is easy to locate. Firstly, since the full length, the horizontal length for the rectangle shaded here will be what? What will be the horizontal length?
200.
200. The same way, the height, according to what we are seeing here, it will be 150. So the area for this piece will be 200 by 150. What is the product? So we get 30,000. So the area for that segment has turned out to be 30,000. Next, what will be its x-coordinate at its center? At its centralmost point, since the edge here is at 0, 0, we know the centroid will be exactly midway. It will be 100 from that 0, 0 and half of the 150 in the vertical axis. So the x part will be from here up to the centralmost point, which is 100. Direction is important. If it's to the right, positive, to the left, negative. So in the vertical, we know we have to go up to halfway of the full height. The full height is 150. Halfway is going to be 75. We're okay there, right?
Yeah.
So we can even get the products in advance. So first we have 30,000 multiplying 100. What are we getting?
So,
3 million, right? Okay. In the same way, we now multiply 30,000 by 75. What are we getting? 2 million? 250,000 like this?
yes.
Okay. So that completes segment 1. Now, we want to account for the pieces being cut out. So if the area is going to be cut out, you must indicate it with a negative since it's being cut out. Do you get that? So first, I'll cut out the triangle on top. The triangle on top, when I cut it out, it's basically this one here. You see that? So let's account for it. We'll draw the coordinate system with only that triangle. Sorry, analyze it on its own as well. As if we were trying to get the centroid for that one. The triangle is this side. So we know to segment all the way up to there, that is the 200. Going all the way from bottom from 0 up to the top, that is a 150. So first for a triangle, we know to say the area of a triangle is half BH. What would our B in this case? No. Will it be? Yeah, it can be 200. That's fine. And what would be our H?
70.
What would be our H? It's what?
50.
50. Good. So you have to see that it's this one from here to here, multiplying from here to there, right? So you're almost making a mistake. I heard you say 75, then 100, then... So it's going to be that 50 multiplying the 200. So this is going to be 5,000, right?
Yes.
So because we are seeing it out, we're recording it with a negative. Next, what will be its exterior? For a rectangle, not rectangle, for a triangle, what is the formula for its centroid? One over what? 1 over?
1 over B to the power 3.
Yeah, spoiling it. It's a coordinate. Once you put power 3, it becomes a volume.
H.
Just 1 over 3.
1 over 3.
You've got that, huh?
Yes.
1 over 3b, and in the y, it will be 1 over 3h. So, in other words, and the thing is, these 1 over 3b, if my triangle is like this, b is like this. So when I get 1 over 3 of b, it will be measured from here going this way. When I get 1 over 3h, it will be measured from here going upwards. In the same way, when I get 1 over 3b, let me take this to be b and this to be h. When I take 1 over 3 of b, my b is a 200. So 1 over 3 of 200. So 200 over 3. What will be that answer here?
56.68.
So this 66.67, it's a measure from the y-axis going this way along the or parallel to the x-axis. So when you look at it, notice that it's the same here. So I might as well say that that will indeed be the x tilde. So we can record it. Now look at y. When you try to find y, it will be 1 over 3 of h. H here is what? 50, right? So 1 over 3 of 50. So we have 50 divided by 3. What are we getting?
0.67.
So this 16.67, it has to be measured from the horizontal. It's measured from that axis going downwards. So remember, x was measured from the vertical going to the right, or it was basically a horizontal line. Y will be measured vertically, so this time it will have to go down. Do you see that?
Yes.
So if this part up to here is 16.67, y tilde has to be measured from the x-axis going upwards up to that point. So how are we going to get y tilde? Yes, 150 minus 16.67. What do we get?
153.33.
That becomes our y tilde. Then we multiply again. What would be 5,000 multiplying this?
So 300. I'm going to say 350. 350.
Like that?
Yes.
In the same way. So see that I've carried the negative as well. It's also multiplying. And here?
6.
Negative. Negative what?
6. 70.
Like that?
Yes.
Okay, now we go for the third one. Notice that there's another section we have to cut out, right? That'll be the third one. So for this one, it's semicircular, this piece here now. So again, I'll draw the coordinate system with only that section in position. So the section is, let's say, somewhere here. So we know from here to here it's 100. And the diameter of this semicircle is also 100. What would be the radius of this semicircle? 50. So one other thing you should keep in mind is that the centroid lies somewhere along its radius, its vertical part there. somewhere along here. That's where it lies. And we expect it to be slightly down. Let's say the radius, the centroid is somewhere here. So it helps when you memorize these formulas for the shapes and their centroids. So do you know the formula for the centroid of a semicircle? The x coordinate will be simple for plane. It will be equals to what?
half and 50.
50 plus what? It will be this 50 from here up to here. This 100 from here up to there. Plus the radius, which is 50. You see that?
Yes.
So x tilde will be a 150. The area, since it is a semicircle, area is straightforward, right? Area will be half the area of a circle. So it will be half pi 50 squared.
That will be 3946.
3926.
0.99.
99. So let's just say 3927, right? But remember that area is being cut out. So you have to insert it with a negative. Do you get it?
Yes.
Now, the y tilde. For a semicircle, y tilde will be given by, or y will be given by, do you remember the formula? 4 over 3 pi over r. Have you got it?
Yes.
So it's r on top, pi down. So whenever you're not sure about which one it is here, remember it's a coordinate, it's a length. So the answer must have the unit for length. This pi doesn't have units, so the r is not bringing the units. So if you swap them, just remember when you swap, the units will be in the denominator. It will not be a coordinate anymore. So you need the r to be in the numerator. You've got it?
Yes.
So that can be, yeah?
21.22.
21?
21.22.
21.22. So that becomes how high you need to go vertically upwards, like that. So this becomes our y tilde. So we go back to our table, y tilde 21.22. So we can multiply now. What will be this times this?
Y to be
For what?
for y
Uh-huh.
to be 83.
Negative 83,
Then 3 again.
3.
3.
Uh-huh.
3 again. 0.94.
Like this.
Yes.
The other 3's.
Yes.
Okay. Therefore, x
It will be negative 589.
589,
050.
like that.
Yes.
Okay, now we get the sum. What do you get when you sum in the x, or the sum of the areas? 21. And then we sum here.
uh, 2, 0, 77, 600.
We do the same thing the other side.
One, 4, 9, 9, 9.
That's all.
1, 9. Again, 1, 9. So I'm saying like 1 and 9.
Oh, 1 then 9.
Yes.
Like that.
10.06.
Okay. So we're done. So you can now get X bar. So sum of X tilde A over sum of the area. So sum of X tilde A will be this. Then we'll divide this by sum of the area. In our area, we have this. So what are we getting? So y dividing this.
$98.59.
That's for X of Y. 98.59.
71.18.
71.18. So we're done. The coordinates of the centroid will be equal to 98.59 millimeters, 71.18 millimeters. So those become the coordinates.